let's talk about something we all think we have a handle on, but maybe we don't. The actual space it takes to stop your car. It's this invisible distance that is, no joke, the difference between a near miss and a disaster. Now, for this deep dive, all the credit goes to the incredible lectures of Aras Zographos, who's a professional driving and traffic education instructor. So let's get right into it. All right, first up, a quick question for you. Picture this. You're driving through town, going about 50 kilometers an hour. That's roughly 30 miles per hour. Suddenly, a ball bounces out into the road. How much space do you really need to bring your car to a full stop? Just think about it for a sec. Is it 1 car length? 2? Whatever you're thinking, just lock that number in your head, because I'm willing to bet the reality is going to surprise you. So here's how we're going to break this all down. We're going to start with what we'll call the safety equation. Then we'll look at that crucial first second, the human part. After that, what happens when you actually hit the brakes? Then we'll get into all the unpredictable things that can change the math, and we'll wrap it all up with one golden rule you absolutely have to remember.
Okay, first things first, this safety equation. This is like the fundamental blueprint for every single time you stop your car.
The big term here is total stopping distance. And listen, the most important word in that whole definition is spot. The clock doesn't start when you hit the brake. It starts the instant your eyes see a problem, and that little distinction, it changes everything.
Yeah, see, that's because stopping your car isn't just one single event. It's actually 2 totally different parts added together. The distance you cover while you're reacting, plus the distance you cover while you're actually braking. Let's dig into that first part, shall we? All right, now for the first piece of that equation, and honestly, it's the most unpredictable part of the whole thing. You, the human element.
Reaction distance. This is the mind-blowing part. It's the distance your car travels before your foot even thinks about moving towards the brake. Your brain is firing away, processing, deciding, but the car, oh, it hasn't slowed down one bit. It is still rocketing along at 100% of its speed.
Aras Zographos uses this perfect analogy. Think about running around as a kid. You see something in your path, you can't just freeze on a dime. You always take a couple more steps before you even start to slow down. That is exactly what your car is doing while you're busy thinking.
So, how long is this delay? Well, for an average, alert driver, it's about 1 full second. I know, that doesn't sound like a lot, right? But trust me, in a moving vehicle, 1 second is an eternity.
And look, this isn't just some theory, it's straight up physics. You can literally prove it yourself with a simple ruler drop test, like you see here. The distance that ruler falls before you can snatch it is a direct measurement of your brain's processing delay. You are not a machine, you cannot react instantly.
Okay, so you want a quick way to figure out this reaction distance in your head? There's a super simple mental shortcut. Just take the first digit of your speed in kilometers per hour and multiply it by 3. That's it.
Let's try it. You're going 50 kilometers an hour. The first digit is a 5. Multiply that by 3, and you get 15 meters. That's almost 50 feet. For a full 15 meters, you've seen the danger, but your foot hasn't even hit the brake yet. Your car just traveled about 3 car lengths, just while you were thinking about what to do. So that's the human part. Now, let's get to the second half of our equation. What happens when your foot finally slams down and physics takes over?
This is the braking distance. It's what most of us actually picture when we think about stopping. You know, the tires screeching, the car lurching forward. It's simply the distance covered from the moment the brake pads clamp down until you hit 0.
And guess what? There's another incredibly handy rule of thumb, but this one is to estimate your total stopping distance. That's reaction and braking, the whole shebang. You just take that first digit of your speed and multiply it by itself.
Let's go back to our 50 kilometer per hour example. First digit is 5. 5 times 5 is 25 meters. That is about 82 feet. So, remember that question from the beginning? It's not 1 car length, it's not 2. It's more like 5 or 6 car lengths. And remember, that's in perfect conditions.
Which brings us right to our next section, because those calculations are just a baseline. The real world is messy, and a whole bunch of things can make those stopping distances way, way longer. First up, let's talk about the things that mess with your brain. If you're tired, your reaction time is about as bad as if you'd been drinking. If you have actually been drinking, that time can easily double or even triple. And distractions? Oh man, glancing at your phone, getting into an argument, all of it adds dangerous milliseconds and meters to your reaction distance.
Now for the physical stuff that affects the car. A wet road can double your braking distance. Easy. Worn out tires or bad brakes? Well, that's a no-brainer.
And a heavy car, maybe packed up for a road trip, it's carrying more momentum, which means it needs a lot more road to come to a stop.
And this is the most shocking one of all. On an icy road, that nice clean 25-meter calculation we just did, you can just throw that right out the window. Your stopping distance can be up to 10 times longer. 10! That's 250 meters. That's the length of 2.5 football fields to stop from just 50 kilometers an hour. It's insane.
Look, I know that's a lot of numbers and factors to juggle, but if you remember just one single thing from this entire explainer, please let it be this. This is the golden rule of stopping distance.
Here it is. The relationship between your speed and your stopping distance isn't a straight line. It's exponential. If you double your speed, you don't double your stopping distance. You quadruple it. This is, without a doubt, the single most misunderstood and dangerous piece of driving physics there is. This chart makes the terrifying reality of that rule crystal clear. At 50 kilometers per hour, you stop in about 25 meters. But if you double your speed to 100 kilometers per hour, the distance doesn't go to 50 meters, it skyrockets to 100 meters, 4 times farther. Our brains are just not built to intuitively grasp that kind of jump.
So let's end where we started. We now know about this invisible space our cars need to be safe. We know it's made of both our thoughts and pure physics, and that it grows scarily fast with speed. So my final question to you is this. Now that you know the real distance, are you ever going to look at the gap between you and the car in front of you the same way again? Something to think about.